Hey, today I will show you several homework problem solving of chapter 4. Question 9. Identify each of the following substance as a strong electrolyte, weak electrolyte, and a non-electrolyte. A, water. Okay. Take a look textbook. We have a table shows which type of compound is a strong electrolyte, which type of compound is a weak electrolyte, which type of substance is non-electrolyte. So strong electrolyte, either a strong acid or a strong base, or any soluble ionic compound. So clearly water is not. Weak electrolyte is either weak acid or weak base, or something like water is a very weak electrolyte. Only 1 out of 10 million water molecule can be decomposed to hydrogen ion and hydroxide ion. So it is a very weak electrolyte. B, KCl. KCl is an ionic compound, right? Cation ion from group 1A, anion from group 7A. And this we can also call a salt, similar as table salt in NaCl. So strong electrolyte, clearly. C, HNO3, this is strong acid. Nitric acid is a strong acid. So strong acid is strong electrolyte. Completely break down into cation and anion. Nitric acid completely break down into hydrogen and nitrate, where KCl completely break down into potassium ion and chloride ion. AQ means aqueous solution. This means solution in water system. And D is an organic compound, C12H22 O11. This is a sucrose, which is a sugar molecule. So organic compound, sugar or urea or whatever alcohol, this organic compound is non-electrolyte. They can dissolve in water but keep in molecular form. In water, still molecular form, no iron. So this is non-electrolyte. Are you okay? Then next one. Question 21. Ask you write ionic and net ion equation for the following reactions. Let's show you one. A. Silver nitrate solution mixed with sodium sulfate solution. This reaction so chemical reaction, three type combinations, the two reactant becomes one product, or separation, one substance break down the self becomes two or even more than two, or rearrangement. So this is a rearrangement. Silver initially bind with nitrate, now silver bind with sulfate. Sodium now bind with nitrate. So this is a rearrangement. So silver is positive one charge, so we need two silver bind with one sulfate. The sulfate is negative 2. Why sulfate is negative 2? You see, this is sodium is 2 there. Each sodium plus 1. Then sulfate must be negative 2. And the silver is positive 1. That's why we need two silver bind with one sulfate. And sodium now bind with nitrate. 2 sodium, 2 nitrate. And then we need 2 sodium nitrate. And the sodium is a compound. This compound must be soluble, right? Take a look at the period, the textbook, chapter 4. We have a table. It's about the solubility rule. Which type of compound is soluble? Any compound has sodium ion. This group 1A metal ion. Any compound has group 1A metal ion, always soluble. On the nitrate, this uniron part, nitrate also tell you soluble. Any compound of nitrate is there, always soluble. That's why we label AQ. And this I explain is a sulfate compound, mostly soluble. But if silver bind there, then it's insoluble. So this is solid. Okay, this is solubility rule tell us. Okay, so this we call molecular equation. Now write ionic equation. So any soluble compound and soluble ionic compound break down into ions. So 2 silver ion plus 2 nitrate ion. And these 2 sodium initially bind with not one sulfate. Now breakdown becomes 2 individual sodium ion. So these 2 need mode to in front. Okay. No more bind together, so these 2 must be in front of sodium ion. And sulfate is negative 2 charged. Whenever you see S, which is a solid, so don't change it. Silver sulfate solid. As the AQ, aqueous solution of ionic compound, and break down into ions. So this we call ionic equation. Now how can we write net ionic equation? Just find out which ion show up in both sides. This means that ion that are not actually involved in the reaction we call spectator ion. So sodium, not actually involved in the reaction. And nitrate, right? Then left over the reaction only between silver ion and sulfate ion, produce silver sulfate. This is a net ionic equation. Okay. Next, 39. For the following complete redox reaction, break down each reaction into its half reaction and identify oxidizing agent and identify the reducing agent. Let's show you D. Magnesium react with nitrogen. Produce magnesium nitride. So first, break down this complete reaction into two half reaction. This means these two reactants. Each half reaction is for one reactant. So magnesium becomes magnesium iron. So magnesium, take a look at the periodic table. Magnesium from group 2A should be positive 2 charged. So magnesium metal 0 charge becomes 2 charge, it means lose 2 electrons. Then 3 magnesium lose 6 electrons. Then the other half is nitrogen gas, gain this 6 electron, becomes 3 negative charged iron. Okay. Then which one is oxidizing agent? Which one is the reducing agent? Reducing agent always metal. So here magnesium is a metal. Because only metal lose electron. And the reducing agent is lose electron. Be oxidized. Or oxidizing agent sometimes is no matter. Here nitrogen is no matter. Sometimes could be a metal ion. Okay. This is 39. I show you one 39D. The rest is similar. Actually, we already showed one 39A in the class. Okay, during the class. Okay. Then number 66. Question 66. You have 505 milliliter of 0.125 HCl solution, and you want to dilute it to exactly 0.1 molar. How much water should you add? You have 505 of 0.125 molar HCl, and you want to dilute it to 0.1 molar HCl. Add water to it. Ask you how much water. What is the volume of water should you add? So a concentrated solution, add water. Water is a solvent. Then becomes dilute solution. So this is a dilution problem. The dilution problem, we have a formula. Mi times Vi equals to Mf times Vf. Right. Mi is the initial concentration. Is this before dilution? 0.125. Vi initial volume. Here, 505 milliliter. Mf is 0.1. So from this formula, we can calculate Vf. Vf equal to Mi times Vi divided by Mf. Mi 0.125, Vi 505, Mf is 0.1. This gives us the Vf is 631.25 milliliter. So Vf is a final volume. Here asks you how much volume. So add this. Asks you volume of water should you add. So volume of water, you add to this solution, then total final volume is this Vf, right? So your volume of water should be Vf minus Vi, because Vi plus water equal to Vf. So water equal to Vf minus Vi. Vf is 631.25 minus 505 should be equal to 126.25 milliliter. So during the quiz or test, you need to read the question carefully. Here asks you the volume of water should be added, not asking you the final volume. So you need one more step. Final volume minus the initial volume give you volume of water should be added. Okay. And one more question from homework is 72. Okay. The concentration of sulfate in water can be determined by adding a solution of barium chloride to precipitate the sulfate ion. Write the net ionic equation for this reaction. And treating 145 milliliter sample of water with excess barium chloride precipitate 0.33 gram of barium sulfate. Also, you determine the concentration of sulfate in the original water sample. So net ionic equation is barium ion react with sulfate on iron, produce sulfate solid, precipitate. And the sample sulfate comes from 145 milliliter water sample. This comes from 145 milliliter sample. We add excess amount of barium chloride. This means all this be reactive, because this axis is the limiting region. The produce this is 0.33 gram. After you calculate sulfate concentration. Okay. For the mass of this product, we can convert it to moles, right? Then for moles, use this balanced equation, we can find moles of sulfate. Then for moles sulfate divided by volume, we get concentration. How can we convert mass into moles? I wrote this conversion in this area many times. So mass to moles is mass divided by molar mass. If we know moles, convert back to mass is mole multiplied by molar mass. Right? So this mass converted to molar mass. What is the molar mass of barium sulfate? We need to use the periodic table. So barium is 137.33, sulfur is 32.06, and oxygen 16. And then you have 4 oxygen, right? So 16 times 4. plus 32.08 plus 133.3. Together will be 233.4. Then use this more divided by volume. So more molarity is more divided by volume in liter, right? So this 145 in liter is 0.14 liter. So this, now we can calculate molarity will be 0.33 divided by 233.4. This is more because gram cancer left over more. Divided by volume is 1.145 liter. Use calculator because this balanced equation tells us the moles of barium sulfate equal to moles of sulfate because this equation is a 1-to-1 ratio, right? That's why this moles of sulfate, barium sulfate equal to moles of sulfate. Okay, then divided by the sample volume. Use calculator, you get concentration of 0.00975 unit is molarity. Okay. Spend some time after class. We will have quiz in next class.